Hello everyone, welcome back to this new video once again. In this video, we will try to solve a numerical based on Hess law of constant heat summation. So let's have a look at the question at first. What is asked here? Calculate the enthalpy of formation of methane using the following data. So here we have to calculate the enthalpy of formation of methane. And these values are given to us in this way. Let's have a look at the equations. First equation is related to methane, which is burned in presence of oxygen to give us carbon dioxide and water, and the enthalpy change for this process is minus 890.3 kilojoule per mole. What about the second equation? It's about the formation of water molecule, and enthalpy change for this process is minus 285.8 kilojoule per mole. What about the formation of carbon dioxide? Here the change in enthalpy is minus 393.5 kilojoule per mole. So here we need to find out the enthalpy of formation of methane. So let's write the required equation at first. The required equation is that to get methane, which is a gas molecule, so we can write in this way. First, you write the formula in the side of the product. How many carbons are there? One carbon. So we can write carbon in bracket, you write S, plus how many hydrogens are there? 4 hydrogens. So we cannot write 4H. So better to write as H2 because it exists in the form of a gas. So we will be writing here gas. Now how many hydrogens are there? 4. So we can write 2H2. So this is our balanced equation. So in order to find out the enthalpy of formation of any compound, first of all, we have to remember that we'll be writing about the product at first. Then by looking at the formula, we'll be trying to write the balanced chemical equation in the reactant side. Now, where to get this carbon? Let's look at this equation. This carbon is present here. And how many moles are there? 1 mole, and here also 1 mole. What about H2? 2 moles of H2 are here. Let's search here. Okay, if you look at equation number 2, then we are getting H2. But how many moles are there? 1. And how many they have given? 2. So what idea is coming to in our mind? That if we multiply this equation by 2, then we'll be getting this value, isn't it? So let's do one thing. Let's multiply equation 2 by 2. So what will be getting? 2H2 plus, here we'll be getting O2, isn't it? 2 into half gives us 1 O2 arrow. 2 into 1, 2H2O. We'll be getting liquid. And this enthalpy will also be multiplied by 2. Remember, the complete equation will be multiplied by 2. So, the new value of enthalpy will be 571.6 kilojoule per mole. And let's assign this equation as equation number 4. Equation number 4. Because this is equation number 3. So what can be done now? We need C plus 2H2. So we have already got 2H2 and C is already here in equation number 3. So what can be done? We can add these two equations. So let's add equation number 4 and 3. By adding this one, we will be getting, we can write here equation 3 plus equation 4, which gives us C plus 2H2G, 1 O2 and 1 O2 gives us 2 O2. Arrow, what we are getting here? CO2 plus H2O, 2H2O, because 2H2O is here. And now what we have to do, delta H will be what? Delta H will be the summation of this value and this value, isn't it? So this way what will be getting? Minus 965.1 kilojoule per mole. Now you see what we require now. We require CH4. So where to get this CH4? We can get this CH4 from equation number 1. But here, if you look at equation number 1, also 2O2, CO2 and 2H2O are present. But what we need to do? We need to cancel out these terms. So that can be done if we subtract this equation from this equation. What I mean to say, if we say that this is equation number 5. So if you do equation 5 minus equation 1, definitely we'll be getting this equation, isn't it? You look, equation number 5 is this one, C plus 2H2 plus 2O2, which gives us CO2 plus 2H2O. So if we subtract this equation from here, so 2O2, 2O2 will be cancelled out, CO2 and 2H2O will also be cancelled out, isn't it? So what will be getting? Equation 5 minus equation 1, which will give us C plus 2H2. These terms will be cancelled out because we are subtracting equation number 1. So you must be thinking that minus CH4 will be here. Of course, we can write here minus CH4, or better to write CH4G. What I have done here, I have shifted or transposed this minus CH4 in the product side, and this will become positive, isn't it? Remember, we can shift it to the product side. So we have got our required equation. And what is asked in our question? To calculate the enthalpy of formation for this process. So enthalpy of formation will be very easy. This is minus 965.1 kilojoule per mole, and this one is minus 893 kilojoule per mole. So if you are subtracting this equation, this will become positive. So our ultimate result might be 74.8 kilojoule per mole. I hope you have understood this part. This part will become positive because we are subtracting it, isn't it? So if you deduct this value from here, you will be getting the probable chance is that minus 74.8 kilojoule per mole. I hope this video will help you to solve the numericals based on Hess law. And if this kind of questions are given to you, definitely you can solve it. If you find any kind of difficulties, please ask me in my WhatsApp number. Thank you very much for today.